Kathy, hello. Thanks for letting me come by here today.
Hi, Shelley. No trouble. This is my colleague, Roberto Cano from the Composites Fabrication Laboratory.
So nice to meet you. What's up?
Well, what's up is my friend Van Hughes. He's trying to cook something up, and he's having a little problem with his cookie recipe. Seems that his cookies are way too hard. They're not chewy, and they crumble very easily. Well, Kathy, we saw you today on the WVECU Cooking with the Stars program and thought maybe here at NASA Langley, where you are involved with the Composite Materials Laboratory, that there might be a recipe that you have that could help us, or some things that you do that could give us some advice to help Van in his problem.
Bert and I would be glad to help. In fact, the process that Bert and I follow in the Composites Fabrication Laboratory might offer a solution to Van's problem.
Oh, that's great. But now I got a question. What is a composite material, and just how is a composite material made?
A composite material is made of two or more different materials. Composite materials have been used throughout history. For instance, ancient Egyptians used a very basic composite material in the construction of their houses, straw and mud. They combined these two materials to make a third, stronger one, brick. One of our goals at NASA Langley is to develop stronger, more durable, lighter weight materials for use on airplanes and space vehicles. NASA Langley Research Center is the agency's center of excellence for structures and materials research. We can identify 5 steps in composite development. Van may use similar steps in planning and preparing a cooking recipe. Identify the application, develop materials to meet requirements, process the material, test the material, and make structural components.
Okay, how about it? Could you give me some examples of how these steps work for composite development?
Glad to. Let me explain the first step. NASA has challenged their researchers to find ways to make planes and space vehicles tougher, stronger, lighter, cheaper. Our job as researchers is to develop new materials or to improve on existing materials. My work at NASA Langley involves development and characterization of polymers. A polymer is a huge chain-like molecule built up by the repetition of small, simple chemical units. Polymers can be flexible or stiff, tough or brittle, strong but lightweight.
Okay, so what's the next step?
Well, for a structural application, the polymer needs to be reinforced. Typically, this is done with a carbon fiber. And one way we combine the carbon fiber with the polymer is to make a Prepreg tape.
Prepreg tape?
Well, let me show you what I mean. The principle of prepregging goes back to the early days of aviation. The planes were made of a wood structure covered with a skin of fabric coated with glue. This combination of the glue and the fabric was a form of composite material. We developed a prepreg material that combines the NASA Langley developed resin system PETI 5 with the carbon fiber IM7. This material was developed for applications for commercial supersonic aircraft. To fabricate IM7 PETI 5 prepreg, many ends of IM7 carbon fiber are introduced into a dip pan. In the dip pan, the fibers go over and under a series of bars. When the resin solution is poured into the pan, the bars help force the resin into the fiber bundles. The now coated fibers exit the pan and go through a series of ovens and nip rollers. The oven and nip rollers process the material into a uniform tape that is taken up at the end. This tape is referred to as prepreg and can now be used to make composite parts. As layers of the new material are processed together, it creates a tough structure that is lighter than metal, but is strong and is stiff.
Well, this has been fascinating, but what pointers might you be able to give to me so I can pass on to Van with his cooking problem?
Given that Van's requirements are soft and chewy cookies, I recommend using half butter and half Crisco, baking the cookies at 350 degrees Fahrenheit in a preheated oven for about 8 to 12 minutes.
Also, to make the cookies more chewy, he could add oatmeal, raisins, or chocolate chips. But also, when you make a composite material, you need to test it to see how well it performs. So I would recommend that Van test his cookies before he serves them to anyone.
Shelley, I'd recommend you talk to David McGowan and Dr. Ted Johnson. They have a lot of experience in area testing.
Fantastic. I'm going to give Van a call with the information that you've shared with me. Then I'm going to be on my way. So thanks so much for all your help today. Appreciate it.
You're welcome.
Okay, Van, did you get all that?
I've figured out some of the ingredients, and now all I'll have to figure out is the quantity of the ingredients. And then I'll follow some of Kathy and Roberto's ideas on the oven temperature, baking time, and the properties.
Okay, great, Van. Meanwhile, I'm going to head on over to the materials testing and see what I can find out, and I'll give you a call back.
Oh, okay, but it smells like I have some butter burning on the stove, so I'll talk to you later.